Okay, so what I'm going to talk through quickly now is making salts. Now before we finish, we didn't have time to go through this properly, so I'm going to try and explain it now. So there are two ways of making salts, and salts can occur naturally in rocks and things like that, but we can make them as well. So we can make them by using an acid and a metal to produce salt and hydrogen, or we can use acid and a base. And before our previous lessons, we know that base is an alkali. So an acid and a base can produce salt as well, but it will produce water instead of hydrogen. This is all about how the ions switch around and attach to each other and what we've got left over. So I've got examples of each. So for the first one, our acid is sulfuric acid, our metal is zinc, and they form zinc sulfate. So we can see that the zinc and the sulfur have joined together. This leaves some hydrogen left over. Okay, so we can see the combinations of the elements have swapped around, leaving hydrogen and the salt. The zinc sulfate is the salt. And then the other way we can do this is, so the acid and the base. The acid in this example is nitric acid, the base is going to be copper oxide. These form together, so the copper and the nitric acid form together, forming copper nitrate, and they leave H2O, so water molecules left over. Now ways of actually making the salts. So if we did go ahead and do the practical and make the salt crystals, this is how we would do it. So reactions of acids with metals or bases make salt solutions, as I've just gone through. Removing water makes salt crystals. These diagrams show how to make copper sulfate crystals. So this is the practical we would have done. So what we would have done, we would have used our we've got a measuring part, glass cylinder. We would have put a dilute sulfuric acid, so a weak sulfuric acid solution in there. We would have put some copper oxide powder, which we know is a base for my example. So you'd add the copper oxide powder to the dilute sulfuric acid, keep adding some until the copper oxide is left over, so until it stops dissolving. All the acid is now reacted. What you'd then do is we'd get a conical flask, and we'd get a funnel, and we put some filter paper in the funnel, and what we're trying to do is we'd pour this solution into there, meaning that we just have the copper sulfate solution left over. So the copper and the sulfate have now attached to each other, so we've got the copper here and the sulfuric acid in the solution here. They have now attached to each other, and that's what we've got left over here. So once we've filtered it, we then need to go to stage 3, where we would have got our Bunsen burners out, and we would have heated that solution that we've just filtered through the paper. We would have had an evaporating basin here, which means that this bottom part is heated, and then particles would evaporate off. So heat the copper sulfate solution in an evaporating basin until most of the water evaporates. So we'll be heating it to about 100 degrees Celsius, and that means the water would evaporate into steam and it would go away, sort of into the air around us. And this leaves us with copper sulfate crystals. So it just leaves us with the copper sulfate. It takes the water out of that solution and just leaves us with the copper sulfate. And then you can leave them for a little while, and the crystals will grow. It depends how quickly you've done this process. If you've done this process slowly, you'll get bigger crystals. If you heated it really quickly and the water's evaporated really quickly, you would have got smaller crystals.